In this session, we're going to discuss minimization of the FA. If we say minimization of the FA, it means that we are minimizing the number of states of the given automaton. So for example, our DFA have 5 states, we're going to make it to 4 states. Why? To make it more efficient automaton. So by reducing the number of states, we'll make the processing of our data in a less number of phases and less number of states to get the output. Okay? And how do we minimize? So by removing the equivalent states. So we're going to determine which among the states are equivalent and then remove the redundant states. Okay? So how do we determine if they are equivalent? So let's consider first where X is an input string. So where the transition is Q1, X is equal to transition of Q2, X. When Q1, Q2 encounter the same input, it will go to a final state. Okay, so it means they have the same behavior, they are equivalent. Or if they encounter the same input, same string, it will go to the same state, which is non-final state. Okay, so if they go to the same non-final state, okay, when they encounter this set of inputs, therefore they are equivalent. So in short, the behavior should be the same so that they could be considered as equivalent. So further explanation of this will be on the next video lecture. Okay, I will give examples so that we could determine which among these sets or these states are equivalent. Okay, so let's have this example, simple example. So let's consider C and G. How does it behave when encounters 0, 1? It will just loop within itself. Am I right? For C, 0, 1, loop it within itself. G, loop within itself. And C and G are end state or final state. So do we need both states in our automaton? If they behave, if the behavior is the same? Definitely no. We could combine them. Instead of separate 2 states for C and G respectively, let's combine them since if they encounter 0 and 1, they are end state, we could group it as one state. Okay? So by doing this, we remove one state. Another question. Can any other state be unified because any subsequent strings of access produce identical result? So aside from CG, is there any states that behave goes to the same states when encounter 1, 0? Yes. Let's consider B and F. So what can we notice? So if string ends reject in both cases, so if next character is 0, where will it go? Both will go to CG. B, CG. F, CG. How about 1? It will go to E. Am I right? Yes. So therefore, B and F are the same. They are equivalent. So therefore, you could unify B with F. So now, by combining these two, now we have this new automaton. So we have combined CG, combined BF. Okay? Can we make this automaton more simplified? Yes, by removing useless states. What are the useless states? One is trap state. Second is unreachable state. So earlier on the previous slide, we have D here. Okay, so why did we remove D? Let's go back to the previous slide. As you can see here, no state can reach D. Am I right? If you're going to remove D, there's no effect on the automaton since initial state A cannot reach D. There's no path going to D. So therefore, since we cannot, it doesn't interact with the flow of the whole automaton, therefore we could remove D. This unreachable state could be removed to have a more simplified automaton. So let's remove it. Now we have this. Okay, so trap state, unreachable state need to be removed and then combine state with the same behavior. And then we have the simplified or the minimum DFA. Okay, so just review what this minimization of DFA means. Our goal is to contain no useless state, no two distinct states are equivalent, and it should be irreducible. It means irreducible means it's already minimal DFA. It's already in minimum state, minimum automaton. We cannot remove anything anymore. Okay? And also in minimization of DFA, we have these types of equivalence based on the length of the string that we are comparing. So let again, where x is any input string, if x is equal to 0 length, then A and B are said to be 0 equivalent. Okay, and then if x is equal to 1 length, then A, B are said to be 1 equivalent. Then x is equal to 2, so it means length of 2 are equivalent between A and B. So 2 equivalent, and so forth and so on. So the example of these equivalents, type of equivalence, will be further discussed on the next video lecture. Okay, so this will be my end slide for this video lecture. See you on the next video lecture. Thank you for listening.